Hello and welcome back to Quay Does Leetcode. Today I'm doing problem number 104, maximum depth of a binary tree. So for this problem, you're given the root of a binary tree and you need to return its maximum depth. So what is the maximum depth? Well, the maximum depth is the number of nodes, so you're going to be counting nodes along the longest path from the root node to the farthest leaf node. So for this example tree here, you start at the root node and you go down the longest path. So there's one path here and you count the nodes 1, 2, 3. There's also another longest path this way, 1, 2, 3, 1, 2, 3. So the answer is 3. That's the longest path. So, that's how you get it from a picture. But how can you programmatically calculate the maximum depth? Well, one thing you can do is think recursively. So, if we're doing this recursively, what's our base case? Well, our base case is when we get to a node that is pointing to none. If we are at a node that is pointing to none, then what would our maximum depth be then? Well, there's no nodes, so this would actually be 0. And so then what would be the maximum depth of the node that is right before none? Well, we would count, we would get the maximum depth of the right tree and the left tree. So there's none here, and this is 0. So we would get the maximum depth of the left tree and right tree. So we do the max of the left and the right. So this is 0 and this is 0. So we get 0. And then we need to add the node that we are actually on. So plus 1. So in this way, this is 1 right here. So this is 0 and this is 1. What is the max depth of this node? Well, there's 1 here and there's 1 here. So it would be max left and right plus 1. So it'd be 1 plus 1 is 2. And then what's the max depth on this node? This is 1. And then what is the max of the root? So it would be the max of the left and the right plus 1. So the max of the right is 2, the max of the left is 1. So we take the 2 and we do 2 plus 1 is 3. And that's how we get our answer. So essentially, you're starting from the base case, which is 0, and then the simplest case for a node that actually has a max depth is just 1. It's a node by itself that doesn't have any children. So you count up the max of the left and the max of the right. You do the max of the left and the right, and you add 1 to it. So that's the algorithm. This would basically be, you only have to traverse all of the nodes. So this would be O of n time, and you would have to, it's recursive, so you'd have to have O of H, the height of the tree, space. And so let's see this coded up. So first we have to take care of the base case. So if not root, if there is no root node, if you're not on a node, then you want to return 0 because the max depth is going to be, there's no nodes, it's going to be 0. Otherwise, you want to return the max of root max self dot max depth. So you're going to go recursively into the root dot left node, and you're going to go recursively into the root dot right node, and you're going to get whatever that depth was, and then at the end you're going to add 1 to it because of the node that you're currently on. So let's run this, and we're getting correct answer and submit, and that is it's passing submission, so it's the correct answer. Again, this will run in O of n time for the number of nodes, and O of h space the height of the tree. Thanks for watching, and I'll see you in the next video.